So the problem that we have with getting a speed at a certain exact time is that in order to do distance over time, we need non-zero distances and times. So we need to choose an interval over which to find the speed. So we have one team member. I'm going to call this team member A. So we call this strategy 1. We're going to call it A right there. And that person decides to go from t equals 5 to t equals 25. So it's saying, okay, and this looks like a broad interval, but it's to illustrate the point. So what if you went from t equals 5 to t equals 25? And that's what the red team's going to do, team A. All right, and then our second team member is going to do what says, I like the 20-second interval. We're going to do 5 to 25. That's a 20-second interval. But let's do from 25 to 45. So if I do the time from the 25 seconds and then go to 45 seconds, let's put that over here, I guess, t equals 45. And that's what the team B is going to be. That's going to be our strategy B. So that's the interval for strategy B. This is the interval for strategy A. So first of all, just to compare those two, so you see what the fundamental problem is, if I do the speed from 5 seconds to 25 seconds, and I do the speed from 25 seconds to 45 seconds, which speed is going to be higher? All right, the 25 to 45 seconds is going to be higher because the object's accelerating. It's going faster. All right, so now one thing that you probably thought right away is like, all right, well, why don't we, instead of going like all the time before, all the time after, why don't we take a little bit time before and a little bit time after? That's what the third team, which we're going to call team C, is going to do. So they go from t equals 15 to t equals 35. And that's team C's interval. And then your fourth member, team D, they say, what we like about the third team is that they centered the interval at 25. So instead of going all before, all after, that's going to have to be inaccurate. Let's say we center on the interval, but instead of taking this long 20-second interval, why don't we take a short 10-second interval? All right, so it's 10 seconds. So we're going to go from t equals 20 to t equals 30. So this is what team D is going to do. They're going to go from 20 to 30. And that's what team D is doing. So essentially what this is illustrating is each of the teams has chosen a different interval of time over which to calculate the velocity. Now, they're all going to get different results. So now let's just investigate the results that they get. So, first of all, our governing equation for all of this is, I want that to be black, not red, is going to be y of t equals 120,000 minus 1.17 t cubed. All right, so our first team, team A, is using the interval from 5 seconds to 25 seconds. So what are we going to have to do to get the rate? We're going to have to get the change in distance and the change in time. So we're using rate as the change in distance over the change in time. All right, so we need to know what y of 25 is and what y of 5 is. And I'm going to try to be consistent with putting the larger time element first, just like for slope. Right? Remember another analogy is slope. We do y2 minus y1. So it's under this sort of convention that y2 is going to be a larger number. So if I do y2 minus y1, I'll get the positive change. But of course, that's not necessarily going to be the case. We end up with a negative rate of change. In fact, the object is descending, so I expect a negative rate of change. All right, so we're going to start by finding these things. Now, we're going to learn all kinds of cute calculator tricks. These are going to be important for your AP exam. So one of the first tricks is I have a certain equation and I'm going to have to evaluate it again and again and again. So a simple way to do that is to go into press y equals like you were going to graph it. You're not going to graph it, but pretend you're going to graph it. So that's 120,000. Make sure I got the right number of zeros minus 1.17. 1.17. It's t cubed, but your calculator only uses x, and I put to the third power. So I'm going to do all this in terms of a TI. If you want to see how to do this on the Casio, some things are different. Maybe you'll just figure it out. All right, so there's my equation. Now, here's the cool thing that I can do to get y of 25 and y of 5 and all those things is when I quit out of here. So here's a really nifty trick that you wanna, the first time you do this, it's like kind of irritating, but once you get the hang of it, it's gonna make things go very quickly. So it goes like this: vars for variables. You pick y vars. We want the y variables. So you arrow over and then you press enter. All right, there's a list. We want y1. Later on, we're gonna use some of the other ones. We're gonna start with y1. All right, and then I have y1. Now all I do is parentheses 25, enter, and it tells me what y of 25 is. So that, saved me, not only saves me plugging into this equation, but it's going to save me doing that again and again and again. So this is 101,718.75. Now here's where this is really going to pay off, because I can come up and copy this line just by highlighting it and pressing enter, and it copies the line. Now I just come over here, delete the 2, by hitting delete, and now I've got y1 of 5, and I don't even have to go through the rigmarole of getting the y functions again. I press enter, and I've got 119,853.75. All right, so now I can find out what delta t is. What delta y is. So delta y is going to be y of 25 minus y of 5, and that's going to equal, now watch another nifty trick. Unfortunately, I think the older 84s and definitely the 83s don't do this, but I'm going to go up and highlight this number and press enter, and it copies it down. I don't have to retype it. Then I'm going to push minus, and I'm going to go highlight this number, press enter, it copies it down. And then I just press enter, and I get negative 18,135. Why is that answer negative? Because the object is descending. Its altitude is becoming less. Its altitude is decreasing. So in fact, I'm going to expect the velocity here to be negative. Okay, so there's a couple quick calculator tricks, and I'm going to run through a little bit more of this in our next video and just sort of reinforce those calculator tricks.